Hello everyone, we're going to be doing some limiting reagent problems today, and I want to do this first set. Okay, so I'm going to be doing these for you, and then I'm going to balance this guy for you, and then you're going to be in charge of this and this and this. Okay, so you're going to be doing those three yourself. So that's kind of the plan today, and I'm going to kind of go through this as quickly as I can. This is being recorded and is actually going to go in, I don't know, I'm trying to decide if I want to do an ed puzzle or if I just want you to watch it and get reference. Probably just watch it. So here we go. This first problem here says 4,000 grams of heptane is combusted with 7,000 grams of oxygen. Okay, and as it is, it's going to produce carbon dioxide and water, which makes sense because we all know that a combustion reaction is exactly that. It's something that's going to produce oxygen and CO2. So let's go ahead and we need to, step one in all stoichiometry problems, step one every time is to balance the equation. So let's go ahead and write this equation and see if then we can balance it. We have C7H16. And it's going to be a combustion reaction, so we know that's going to be burnt in the presence of oxygen. And when it is, it's going to give off the same product as any combustion reaction, which is going to be CO2 and H2O. Okay? So that's going to be the raw or the skeleton equation. Now we need to balance that. Well, to balance it, we have to take attendance. And to take attendance, we're going to be dealing with, let's see, we've got carbon, we've got hydrogen, and we've got oxygen, right? So let's go ahead and figure out what we have of each. Let's see, on the reactant side we have 7 carbons. On the product side, 1. We have 16 oxygens over here, and we have 2 over here. We have 2 oxygens here, and we have 3 oxygens over here. We have 2 here, and we have 1 there. So now let's go ahead and let's see what we can do to balance this by using coefficients. So the first thing I'm going to do is I'm going to go ahead and put a 7 on this side, right? So I'm going to put a 7 here. And that's going to give me 7 carbons, but it also gives me 7 times 2, which is 14, plus another oxygen. That gives me 15 oxygens over here. Now I'm going to balance my hydrogens. And I've got 16 over here, which means I'm going to need to have 16 over here, which means this is going to have to be an 8. If I put 8 there, now I've got 16 hydrogens, but what happened to my oxygen count? Well, there's 14 here plus 8 there. That's going to equal 22. So this number just became 22. Now that I know that, what do I need to put over here in front of these oxygens? Well, if I put an 11, 11 times 2 is 22, and that's going to give me my 22 that I need. Okay? So let me get rid of my doodles. Got it all balanced now. But I want to try to keep it neat, so I'm going to just go ahead and get rid of the doodles there. Okay, back to this. Now I have a balanced equation. Number 2, the next thing that I need to do is I need to figure out what is the limiting reactant. Well, to figure that out, I'm going to have to do 2 different calculations and then pick the one that produces the least amount, because that's the one that's going to produce the least amount of product. And we know that the limiting reactant is the one that produces the least amount because that's the one we're going to run out of first, okay? So I'm going to have to do 2 different calculations. I'll do one in green and I'll do another one in a different color. So let's do the first one. We're going to do 4,000 grams of heptane, and I can just choose. Do I want to figure out grams of carbon dioxide or do I want to figure out grams of water? It really doesn't matter which one I choose. I just know that whichever one I choose, the limiting reactant is going to give me the smallest amount, right? So how about let's try water. We'll just do the water ones. So let's see.
I finished them both.
Okay. Okay, that's great. You can go as soon as you're done.
All right. Now I also think
Hold on.
we should take a field trip there.
Oh, you do? It'd be great, right?
It'd be pretty cool.
Oh, yeah. See you later. I have a cat problem and I have e-learning going on. Okay, back to this. So I'm going to do 2 different problems. So problem A is going to be using the 4,000 grams of heptane. So here we go. I've got 4,000 grams of C7H16. Okay, and I want to convert that into grams of water. I'm just going to pick water because I want to figure out water, okay? So I know if I take 7 times 14 or 7 times 12 plus 16, I'm going to get 100. 100 grams of C7H6 is going to equal 1 mole of C7H6, 16. How do I know that? Well, that's the molar mass, okay? And we have to have molar mass in order to go from grams into moles. So now we have grams into moles, but I don't want moles of heptane. I want grams of water. So let's keep rolling here. Let's see. I know my mole ratio between water and heptane. This is a 1, right? And then this is an 8. So it's a 1 to 8 ratio. So I write 1 mole of C7H16 on the bottom, and I write 8 moles of H2O on the top, and that gets rid of my moles. My grams are gone. My dogs are attacking a cat in there. They play like this, and it's so annoying. Okay, so then the next thing I need to do is to go from the mole ratio of, and I'm into moles of water, and I need to get into grams of water. Well, I know if I have 1 mole of H2O, that's going to equal 18 grams of H2O, okay? So now moles are gone, and I'm left with grams of H2O. Now all I have to do is the math. We've done the English, now I have to do the math. So here we go. 4,000 times 8 times 18 divide by 100 equals, and I get 5,760 grams of H2O. Okay, so that's the first one. Now I have to do the second one, and I want to do it in a different color just so we don't get them all confused. We'll do this one in red. So I have to do this one, and then we're going to compare them, okay? So this time I'm going to use the 700 or 7,000 grams of oxygen. So let's put that in, 7,000 grams of O2. I'm going to have to do the same kind of calculation, only this time with O2 into H2O. So let's see, I know that there's 32 grams of O2 in every 1 mole of O2. And now let's look at the mole ratio. I know that there are 11 moles of O2 for every 8 moles of oxygen. So let's put that in here. We're going to put 11 moles of O2 on the bottom, 8 moles of H2O on top. And then finally, the last step is to go from moles of water into grams of water. So I know that 1 mole of H2O is the same as 18 grams of H2O. Moles canceled, grams canceled, and I'm left with grams of H2O again. So now let's do the math. And I bet before I do this math, you see this number's a 4 and this number's a 7. You would inherently think that this one up here is going to be the limiting factor, right? Well, let's do the math and see. 7,000 times 8 times 18 divide by 32 divide by 11, and I get this, 2,863 or 864, I guess. If I round it, it would be 2,864. Maybe, hold on, 64 grams of H2O. Okay, so which one is going to produce the least amount? So clearly that's not the limiting factor. The limiting factor is this guy right here, because this amount is smaller than the 5,760 grams of H2O that was formed from part A. So what is our limiting reagent? The limiting reagent is going to be this stuff right here. This is the limiting reactant. Okay, is going to be 7,000 grams of oxygen. That's the limiter. Okay, so now let's go on to number 3 here. And number 3, it says, once you've determined the limiting reactant, now calculate how many grams of carbon dioxide is produced. So to do that, we're going to use this guy right here, because that's the maximum amount of carbon dioxide that I can make, right? I have to go with the smallest amount. So let's put it in there. 7,000 grams of O2, my limiting reactant. And this time I'm going to convert it into CO2. So let's see, I know that there's 32 grams of O2 in every 1 mole of O2. I know that well, what's the mole ratio between, whoa, hold on. Just a second here. Back to this. What's the mole ratio between O2 and CO2? CO2 is 7, and O2, of course, is 11. So this is going to be 11 moles of O2 and 7 moles of CO2 on top. Keep going. Now the next thing I do is convert from moles of CO2 into grams of CO2. So 1 mole of CO2 has a mass of 44 grams of CO2. How do you know this stuff, Miss Bowman? Why do you have it memorized? I don't know. I've done enough of them that I just haven't memorized. And also, if you just look at it, it's going to be 32 of these and then 12 of that. 32 plus 12 is going to be 44. It's just not hard. So 7,000 times 7 times 44, divide by 32, divide by 11 equals, and I get this, 6,125 grams of CO2. And that is my answer, okay? That is my yield of CO2. Okay, a lot of scribbles on here. I'm going to help you with this next number 1, okay? I'm going to help you with this guy, and then you guys are in charge of 2, 3, and 4, okay? So I'm going to help you with the balanced equation because it's been a little while. So we're dealing with lead 2 nitrate reacting with sodium iodide to make sodium nitrate and lead 2 iodide, okay? So the first thing I do is I just write down the skeleton equation. So I've got lead, which is Pb. There's a Roman numeral 2, so I know that has a plus 2. Nitrate is a polyatomic ion, and it looks like this. It's NO3, and it has a -1 charge. Okay. It's going to react with, so I put a plus sign, sodium iodide. That's going to be Na, sodium. Sodium has a +1 charge. Iodine has a -1 charge because it's in group 17. So do I need any subscripts here? No, I do not. So I'm just going to go ahead and erase my charges here. Do I need any subscripts on this one? Well, this is a 2 and this is a 1. So we crisscross applesauce, remember that? So that's going to be a 2, and then of course we don't write the 1s. Only the noobs write the 1s, right? All the cool kids leave the 1s off. So there you go, PbNO32. Now let's go to the other side of the equation, the products, lead 2 iodide. Well, that's going to be Pb again. It's got that Roman numeral 2, so we know it's a +2. Iodide is going to be I, and we know that's a -1. Crisscross applesauce again. We'd put a 2 down here, and we don't put the 1 down. So I want to get rid of my charges. There they go. And now I go to the next one, which is going to be sodium nitrate, which I should have written that one first, but it doesn't matter. We've got Na, NO3. NO3 is a -1, Na is a +1, so that works out perfectly. We don't have to have any subscripts on that. Okay, so now we have to balance this. To balance this, we're going to have to take attendance, and that's going to be Pb. There's the alarm. There's NO3, and I'm going to keep the NO3s together. There's Na, and then there's I. Well, let's see, there's 1 Pb, 1 Pb. There's 2 Nas, 1 Na. There's 1 Na, 1 Na, and there's 1 I, and there's 2 I's. So let's see, we have to balance those. What if I put a 2 here? If I put a 2 there, then that's going to give me 2 Nas, but it also gives me 2 I's. And then if I put a 2 over here, that's going to give me 2 Nas, and it gives me 2 NO3s. And now I'm balanced, okay? So I'm going to go ahead and pull these off of here. Goodness, what in the world? Nobody's answering the phone in the office. Okay, so there's that, and now you are balanced, okay? So what's our ratio? We've got a 1. Let's see if I can get it on here. It's a 1 to 2 to 1 to 2 ratio. Okay, those are the mole ratios. So now you, using the stuff that we've learned, you need to do 2, 3, and 4. Once you have those done, you can either write them on your own paper or you can use this PDF and keep editing. It's up to you. Then once that's done, you can turn that in and then you'll get your credit for having it done. Okay, that's it.